The goal of this video is to show you how I achieved this video that I have with the VRAP VR interface. I will do this video because it might not be clear how to achieve something like this with tools that are available with the VRAP VR interface. But actually, if you want to do stuff with the VR interface, you have to uh, take into account that it actually is more of a visualization. So if you do stuff, then it's mostly you have to do it in VRAP. You can use the signals of the controllers in your logic programmed in VRAP to achieve things. And I will show you how exactly I achieved all of this in VRAP. For some people, it might be quite advanced VRAP feature that I will be using, and I might go quite fast for some people, but I think it's still interesting to see how I did this and to give you ideas how you could do the things you want to do with the VR interface. So what was my setup in this problem? In VRAP, I planned a trajectory in task space of a robot, and I actually needed joint angles for the robot. Uh, this robot in VRAP, so this is a KUKA KR16 that is on a track and that can move. But the thing is that it was quite a long trajectory, and you want a trajectory that is continuous, be reachable by the robot. Actually, this kind of robot can do quite a lot, but inverse kinematics is challenging because of many collisions that are uh, between the robot and the car frame here and the measurement device and the robot itself, so also self collisions. So I had uh, coordinates in MATLAB, but we will focus later on that. Not too much actually, because that's not the most important part. The most important part is inside VRAP actually. So let's start by building that up. So let's first analyze what we have already. We basically have all assets like this mesh, all these meshes, etc. And we have the robot here and the track here, which are all, yeah, this is quite, this is normal VRAP stuff. So you should be able to build this up for your problem. If you're interested in doing anything like this. The only special thing is that we have an inverse kinematic uh, element here. And if you see, if you have inverse kinematics and you want it to be continuous, so if you move it with the controller, the n effector, and you want continuous movement, then you have to use damped d squares. That's maybe a tip that yeah, it's logical if you know what methods do that. This is more continuous than the pseudo inverse, but yeah, might be a good trick. So let's now start by implementing the features that we need. So maybe I shall list them first. What we want is to move the sled or the track separately from the robot. Why do we want this? Because we don't want this to move too much. So if you do this like this, and inverse kinematics can change this position, it will change this too much actually for a good trajectory. So that's why we want to do them separately. Another thing is that we will also want to, because in VR we can position it manually, the end effector, but we also want the precision. So we want it to be automatically solved as well to get a low error on the actual position. So that's a separate thing we want to achieve. And for the rest, we have some aesthetic things. So let's now first start by making sure the VR part works. So uh, if you have installed the VR interface, like I have a video about this, then this is straightforward. Just drag this in, and now you can see this in VR. But we want to do more with this, so uh, so this is actually already the solution. So let me uh, remove this so that we can start from scratch. So we are gonna put all the logic of the scene inside a child script. Let me remove this to make it clearer. We're gonna do actually everything in actuation, so we can remove the rest. So step one is that we are gonna do is that we are gonna get all the signals because we want to know what the user does in VR to base our what we do on it. So let's get all information that we want. Uh, so as you have seen in the VRAP installation thing video, everything is passed through to VRAP in string signals. So So the VR interface will make this signal 1 if the user presses the button and 0 if he doesn't. So if we do this, then in variable GE becomes true if the user presses the button and false if he doesn't. So the script we can use this variable to know what the user does and base what VRAP does on that. So yeah, that's now we have the right controller grip, and we also want the left controller grip. And um, I shall now copy paste all the other variables. These are quite the same actually. So these are all the things that can be communicated to VREP from the interface. So these are all the signals that are available right now. And we can do something based on it like this. If G1 is true, then the button is pressed, and then we will do some stuff. Okay, now it's working correctly. So yeah, we will do this later. So that's an important thing ready. So now that we have the different slots ready, then now the first important step is the key inverse kinematics. Let's fix that. So what we're gonna do is we want to move the part separately from the robot anti-factor. So what we let's take do uh, the movement with controller 2. of the end effector. So we make controller 2 a child of the card. This means this will move with the card, so it will move separately uh, from, yeah, its reference frame is in the reference frame of this card. So if you change the card, this will change with it. That's important. And the target should also be a child of this. If this isn't a child of the track, then you will see that if you the inverse kinematics will also change this joint. That's something we don't want. And what we will do then is add two dummies. Yeah, let's call one target, and let's the other one be called tip. And then we can make the tip child of the card. And if we link them now, then we have inverse kinematics between them. Why is this necessary? If we move the target, then the inverse kinematics solution will want to make the tip same as the target. Let's make this actually a child of let set. Then we can make its position initial position 0. Okay, that's this. Now the inverse kinematics is fixed, and we separated basically uh, the card inverse kinematics from the robot's inverse kinematics. We push the grip button, then the controller will follow the movements of the controller. So what we actually want to do is make the tip of the target object a child of the controller. So if the controller moves, then the target object will follow this. That's exactly what we want. So before we can do that, we need some handles of some object. So the first is the sled actually, the what called, because the tip now is a child of the sled, and we want to, if we release the button, that we can put it back there. So these are standard functions. Another one we want is the controller. So get object handle the second controller. Yeah, what we also want is the targets, and we have two of them. Yeah, the name is not that easy. So this one is, let me see, this target, so of the manipulator, and the target 2 is the one the card. So this one's just called target. Um, Let me think. Uh, I think this is all that we need for now. So if the right controller grip is pressed, then we want uh, the this target, because we want to move the manipulator if this happens, to be child of the right controller. So what we're gonna do is uh, set its parent to of the target one to the controller one, and we want to keep it in place. Don't want to change the position too much. And if it's not pressed, then we want to set its parent to the sled again. So that's basically it. Uh, what we also want to do is uh, the other controller. So with the other controller, we want to move the card. So what we want to do is make the target 2 a child of controller 2, and um, you see it wouldn't make sense to put the target of this as a child of the sled. We want to have it be a target of the environment. That's the most logical thing, because we don't want it to move with the target. That would uh, create chaotic behavior. So we set its parent to the environment, and again, no unwanted movement. So uh, let's now fix the inverse kinematics object in VREP. So this inverse kinematic is already set. Let's now make the second one. Again, damply squares. Yeah, redundant. Okay, 3 iterations should be good, but why not make it 10? The tip is the tip. Yes. Please target. That's okay. But uh, yeah, this is actually a sled, so it can only move in one direction. So we're only gonna constrain it in one direction, because it can't move in the other direction. So it wouldn't make sense to want it from. Yeah. Okay. This is running right now, so let's dive into VR and see what it does. Okay, so let me um okay, this is changed. So let me try to show you whether it works or not. So yeah, so now we can move the end effector. with one controller. If I take the other one now, okay, seems like maybe the X is not the right constraint. Now it's loading. So you can also see yeah, there is a bug. Okay, okay, yeah, that's a stupid bug. Okay, so the controller 2 should be here in the controller. Correct, the controller 1, the one we want to move the end effector with, so should be um, the Y constraint was the X constraints, so that was not a problem. That's okay. Let's try it again. Let me show you what the VR device sees. So this one is the end effector, and this one is the card. See, now it works. I'm pressing the blue button. That's the grip. So yeah, that seems to work. I guess this is already quite a long video, so maybe I will cut this up and stop here for this one. So we have this fixed right now. That's a good point to take a break, probably.